I got the new AirPod. Well, no, not all that new, but I got new AirPod Pro 2s when I got my new iPad, and they're great. I mean,
Are
I
they?
like my AirPod Pros 1, but the sound quality is a lot better. The noise reduction is a lot better. They last like 6 hours or more
Oh wow.
without
I
having to
just
put
got
in the
the
case.
I just got the AirPods 4 with active noise canceling because they were on sale for $150.
Okay, so you're doing a little of an echo for some reason.
I'm still the same. I'm in the same kind of
All right.
nothing's different in my environment. Should I turn my mic down?
Um, sure.
Oh,
Welcome everyone. Sorry.
oh, there.
What?
I didn't have automatically adjust mic volume select. Is that okay now?
Talk some more?
Is that better? Testing 1, 2.
No, you're breaking up like hell.
Really?
Yeah, do you have dots in the corner just saying there's something wrong with your bandwidth or anything?
Nothing at all. Maybe I'll try reconnecting and connecting.
All right, let's try that.
Okay, give me a second.
And hopefully it's not me. Thanks for joining us. Sorry for anybody who is here live. We're just having some technical difficulties before we get started. I assume you had the same problem hearing John as I did. It's possible it's me.
Is that
Hey,
any?
can we hear you?
Can you hear me?
Nope, I can't hear you. You're muted or something or on the wrong
No, I've got the
mic.
dots. I think it's you, Craig.
Nothing.
Hello?
Nothing.
I think it's on your end.
Huh. He's writing something in the comments in private chat to me. I think it's on your end. I have green dots. Yeah, but you're completely muted. I was able to hear you before. All right, it could be on my end. The stream keeps going if I leave, right? So I will
Yeah,
leave and come back.
sure. I'll stay here.
Hello.
Hi, can you hear me now?
Yes, I can.
How
I
do I
switched.
sound?
You sound great. I switched to
Okay.
just as I was talking about my new Bluetooth headphones. I figured I'd switch away from them. That was seemed to be the problem.
Okay. Yeah, I got the new AirPod 4s. They were on sale at Sport Check for $150 for active noise canceling too.
Nice.
Yeah.
And do you like them?
They're okay. I don't like how they fit in my ear because I don't feel like they're secure like my Vistas. But
Yeah, ear fit is very particular. It is one of the things that, and I find I like the Bose style with the little wing.
yeah,
They feel that and these ones aren't quite. If I smile or I talk more, they do come loose. You have to kind of keep adjusting them.
yeah.
Anyway, we're running a little bit late, so let me we got
Yeah,
that
I got a hard
open.
stop too. So
Excellent. And so let's jump into. Oh, I don't have my banner up. Banner. And we'll get rid of that other banner. And there we go. Thanks for hanging out with us. Those of you who stood out this long. Let's get into it. The world of quantum physics has just witnessed a groundbreaking discovery that could reshape the future of quantum computing and spintronic devices. Researchers have achieved the remarkable feat of creating magnetic graphene that exhibits the quantum spin Hall effect without requiring external magnetic fields, a breakthrough that eliminates one of the most significant obstacles in developing practical quantum circuits. Graphene, the revolutionary two-dimensional material made of carbon atoms arranged in a honeycomb lattice, has long captivated scientists with its extraordinary properties. When modified magnetically, this wonder material becomes even more transformative, opening doors to unprecedented applications in quantum computing and advanced electronics. What's going on here, John?
Yeah, so these scientists at Delft University, I think that's it. So they've created quantum circuits that work without these massive, expensive magnets, and they did this by layering graphene on top of a special magnetic material called CRPS, which means that we could have ultra-thin quantum devices that are smaller, faster, and more practical than anything we've ever seen. So why does this matter? Well, think of it like finally being able to build a supercomputer that fits in your pocket without needing a refrigerator-sized cooling system. Because, for those of you that don't know, current quantum devices need huge magnetic fields and extremely cold temperatures to work. So this discovery shows we can get the same quantum effects at much warmer temperatures. Though, at this point, it's still not quite room temperature for the quantum effects, but also we don't need it without external magnets. So the quantum spin Hall effects, or QSH, I think we've covered it before. It represents a topological phase of matter where electrons flow along the edges of material in spin polarized helical channels. So in this study, the researchers achieved this by creating a van der Waals heterostructure where the monolayer graphene is placed on the CRPS, which is chromium thiophosphate, which is an interlayer antiferromagnetic material with a Néel temperature of approximately 38 Kelvin. Okay. So the substrate induces both staggered potential and spin orbit interactions within the graphene through proximity effects. So the engineering essentially fundamentally alters graphene's band structure, and that's what opens a topological gap in the bulk while preserving the gapless helical. I always have a hard time with that word, edge states. So super cool. Love that they've got this. What are your thoughts on this? Do you think we're on a path to having a quantum computer in every household?
Well, now that they can put this on chip, I'm trying to understand how electrically charged graphene can create this spin Hall effect in the chip. So it's just, I'm curious to see how all of that is going to work. Yeah. But this is very interesting. We've long heard graphene, that it's the future of everything. It's the new wonder material that can do almost anything. And I love to see it being put to practical use, but I want to see this actually coming out of the lab and being used in other things. But being able, not having to have that external electrical magnets, which is heavily cost from electricity point of view, and being able to run these operations at room temperature is, again, it brings the requirement way down. So we definitely are closer to quantum computers everywhere. And what does that mean when every laptop's a quantum laptop?
Yeah, I can't even begin to think what that means for the general public. I can't even though we've covered so much quantum computing, so much quantum physics, I still can't wrap my head around what would that mean for someone like you or I to have a quantum computer on as a laptop. Can you?
No, because in my mind, I've always thought these quantum computers were closely guarded governmental or major, multi-billion-dollar corporations holds them secretly. They're in one of those sci-fi centers that you got to walk across this catwalk to get to. That's super secure. Yeah, I'd never imagined it being in a laptop where everyone can run around and do their own things, but we are getting that way too. For example, I never really imagined the AI would just be in our laptop. And you've seen some sci-fi ages ago where I think there was some traveler from the future who had a computer the size of a credit card or something that he traveled with. That was a fully AI thing that could do stuff with them, but that was from the future. And so now you sit back and say, now we're doing personal AIs, we're doing all sorts of stuff that are local, or we're training them ourselves and doing that. The future is high powered. It looks like quantum computers with our own personal AIs running all sorts of stuff and working together. It's fascinating, scary, and wonderful looking future when we start looking at this technology and what it means when we can start doing quantum computer at room temperature.
Yeah. So a couple things. The quantum effects, they still require cryogenic temperatures. So the room temperature aspect refers only to the Hall effect, right? The real breakthrough in what we're covering here is that it's eliminating the external magnetic fields, not achieving room temperature quantum effects yet. And so the next challenges that they're going to be facing is fine-tuning kind of the spin-orbit interactions, minimizing disorder, and then obviously scaling up for practical devices. So there's a lot of integration opportunities here, like you were talking about, combining this advancement with existing semiconductor technologies. And there's a potential for creating more stable qubits and quantum logic gates by doing this. So I think this is a huge advancement. I don't know if we talk too much about spintronics and stuff. So like traditional electronics, the way that they work is they use the charge of electrons to process information. And I like the word using spintronics because it talks about how quantum works more. Spintronics uses electron spin as opposed to just the charge of a 0 and 1, if that makes sense. So I like that. I like that there's a lot, and I know we're covering a lot of quantum, but there's a lot of quantum advancement that's happening in the last year as opposed to the last 5 years, if that makes sense.
Yeah, it's really coming along. We've been doing this for a couple of years now, and we had a handful of quantum articles randomly come along at the beginning, but it's more and more almost every week. There's new quantum breakthroughs, and we're really changing. This is taking leaps forward, and we're really going to see, I think, some big changes in this. And that scares me a little bit because as we think we're ready for quantum, like we talked last week about RSA being broken by quantum.
Yeah.
And that looks like it's going to be 20 or 40 years away, but yet we're taking huge leaps forward with stuff like this. And I wonder, is it really that far away?
Yeah, like as these advancements come out, I think that timeline is shrinking as far as getting a practical room temperature quantum computer, because this work represents a first in demonstrating the Hall effect in magnetic graphene without external fields, which is, if you think about it, it's part of a larger global competition between IBM, Google, and other startups who are pursuing different approaches to practical quantum technologies. And so this proximity engineering approach that's demonstrated that we're talking about, it could provide an actual manufacturing advantage by being compatible with existing semiconductor fabrication techniques. And I know I kind of touched on it, but I just wanted to link those two together because that's huge. That's another big advancement is being able to link it to current manufacturing techniques, which will help to scale and commercialize.
Yeah, so the research priorities needs to focus on scaling manufacturing processes for larger magnetic graphene devices, improving interface quality across multiple layers, multiple material layers, developing a standardized fabrication techniques, and creating hybrid systems combining multiple quantum technologies. I'm really looking forward to where we're going with quantum, and we're going to continue to cover it and talk about these things. We'd love to hear your feedback on this magnetic graphene. What are the other practical applications for it other than quantum? And what are you looking forward to? We'd love to hear from you. Scientists at CERN have made history by creating the first antimatter qubit. This breakthrough represents a major step forward in quantum physics research. An antimatter qubit is an experimental demonstration of a quantum bit created from antimatter particles. Specifically, researchers used an antiproton in a quantum superposition state. This allows the particle to exist in multiple quantum states at the same time. The CERN's base collaboration achieved this remarkable feat through their groundbreaking experiment. They demonstrated the first coherent spin transition using antiproton. The particle maintained quantum coherence for nearly 50 seconds, oscillating between spin up and down states. This experiment used sophisticated electromagnetic penning traps to control the antiproton. This represents a major advancement in our understanding of antimatter, quantum physics, and quantum states. While discovery opens new doors for fundamental physics research, it has a limited applications for practical quantum computing.
Yeah.
What's going on here, John?
Yeah, so the base that you're talking about is BASE, which is baryon antibaryon symmetry experiment, which is a collaboration using incredibly sophisticated, like you said, multi-trap system based on penning traps. And these devices use a combination of strong magnetic fields up to several Tesla, which is crazy, and precisely controlled electronic fields. And they're using that to confine these charged particles like antiprotons in a three-dimensional space. And the system consists of two primary components, which is the analysis trap for measuring the precision of magnetic moments, and a precision trap capable of flipping quantum spin states and measuring particle oscillations. So why does this matter? So this isn't about building antimatter quantum computers, because that would be pretty much impossibly difficult. Instead, it's about solving one of the universe's biggest mysteries. Why does anything exist at all? So according to physics, the Big Bang should have created equal amounts of matter and antimatter, which would have completely annihilated each other, leaving behind only energy. But here we are. We're here. We're in a universe made in almost entirely of matter. So the goal of this, by comparing how matter and antimatter behave at the quantum level, scientists are hoping to find the tiny differences that could explain why the universe didn't destroy itself in the first moments after the Big Bang and why we exist. So I think this is cool. This is kind of that existential stuff that sometimes we're talking about. And now we're mixing in science into this. What do you think?
Well, scientists have always wondered around, why we live in a matter versus antimatter universe. What tipped the scale in the favor of matter, and which again, why we exist. And so now we start looking at what we can do at the antimatter qubit level, and maybe we are much closer to solving those mysteries.
Exactly.
Yeah, it's crazy when you think about it. People always hate it when I say quantum is magic, but come on now, we're talking about examining a antimatter qubit on a computer chip to solve a problem on how the universe was started.
Yeah, exactly. Yeah, so this is like, I know this is like really, really technical, and we're getting into like a lot of this quantum stuff is, like you said, magic, but I think that's what people said back in the day when we didn't understand all the laws of physics and things like that, right? So I think that's where we're going with this. But the next major advancement for this particular thing apparently will come through the base step, which is BASE-STEP, which is streaming of trapped antiprotons for precision measurements, which will enable transportation of trapped antiprotons from CERN's antimatter factory to dedicated offline laboratories who have calmer magnetic environments. And so this transportation capability could extend coherence times by a factor of 10, potentially reaching 500-second coherence times and enabling even more precise measurements. And when I was doing my research on this, it made me think there was a movie where they had antimatter that was suspended in a vial, and if it broke out, that it would have, I can't remember how big of a bang it would be, but do you remember that?
Yeah, I that has been a common theme in a few, and I'm sure I know the one you're talking about, just don't know the name off the top of my head. But yeah, let's face it, antimatter and matter can't coexist. If they touch, boom, you get energy, and they annihilate each other. So that's why we need incredibly powerful magnets and vacuums to, CERN's have done some really cool stuff around being able to move antimatter from here to there with these magnets and stuff. So before, it used to have to be studied at where they created it. So now we're taking it a step further by creating these antimatter qubits in a quantum state and being able to study them. As you know, qubits can exist in multiple states at the same time. And as a result, we can now take a look at all of those states and what that means with antimatter. I think this is really interesting. And it exemplifies how targeted innovations can ripple into multiple scientific disciplines.
Yeah.
So I'm really interested in this, but again, we're talking, feels very Star Trek sci-fi when we talk about matter versus antimatter, and we start to get into scary territory, because what are we getting into that can, annihilate us? And, why are we doing that?
Yeah.
So this, would love to hear what your feedback are on this and what the long-term research impact. For example, the antimatter qubit achievement establishes CERN's base experiment as a leader in antimatter research. The future experiments will build upon these fundamental techniques. The research contributes to humanity's understanding of fundamental physics principles. So now, not only can we potentially have quantum computer laptops, but they can be running antimatter processors. Like, the world is changing rapidly, and it's really becoming a sci-fi future world that is coming faster than we can possibly imagine. I'd love to hear your thoughts on this antimatter qubit and quantum states. Are we moving in a dangerous direction, or is this going to open up whole new worlds of, one, science, and two, computing power that we just don't understand yet? All right, let's switch it for a second.
Yeah.
Let me share this instead.
Yeah, just wrong article.
Yep.
There we go.
I think we're good. Nearly 128 million adults in the United States struggle with presbyopia, an age-related vision loss that makes it hard to see things close up. The FDA has recently approved eye drops for presbyopia that could change everything. Viz eye drops, developed by Lens Therapeutics, represents a breakthrough in presbyopia treatment. Viz is the first how do you say that, John?
I don't know. Aclidide-based
treatment approved for presbyopia in the United States. The approval follows extensive clinical research showing impressive results lasting up to 10 hours. So now, instead of using contacts or glasses, you can put eye drops in the morning and have perfect vision all day long. What do you think of this, John?
So yeah, so sorry, it's aceclidine, just FYI.
Thank you.
So I think this is cool. So just to kind of put this into perspective on, like, just to make it simple on how it works. So think of your eye's pupil like a camera aperture. And so how Viz works is it shrinks your pupil to create what's called a pinhole effect, which is the same phenomenon that lets you see more clearly when you squint or look through a tiny hole. So by contracting the pupil to less than 2 millimeters, Viz can extend your depth of focus, allowing you to see both near and far objects clearly without the blurry compromise of traditional presbyopia treatments. I think this is cool. So unlike existing eye drops that can cause distance vision problems, brow heaviness, or only work for a few hours, Viz is specifically designed to avoid these issues. It targets only the pupil, which is the iris muscle, while leaving the focus muscle, which is the ciliary muscle, largely alone. So this means you get improved near vision without sacrificing distance vision or experiencing the side effects that made previous drops impractical for many people. What's cool about this is this, I think, is coming out in October of 2025. So this isn't just research. This isn't something like this isn't like it still needs to go through clinical trials. I think this is ready to be released. What are your thoughts on this, Craig? Is this something that you would use?
I might use it. I am not a fan of contact lenses. I don't like putting anything in my eye, but I have a heart. Like when I say I don't like putting anything in my eye, I don't like eye drops either. But I could get used to it. I think I had issues with my eyes in the past, and now I can't deal with it. So okay, let me explain. I had a metal sliver in my eye, and I had a doctor freeze it with drops and take a metal needle and scrape my eye to get the metal sliver out. And I just your eye is open watching him do it. It was just yeah. So I've got issues with putting things in my eye now, and it's my own issue. I'm sorry I had to share it, but you had to understand my.
I get it.
It's a little different than normal. So the benefits begin within 30 minutes. They peak at 1 to 2 hours and last up to 10 hours. Only 1.3% of people experience mild irritation, 1.1% dim vision, and 0.7% headaches in the trials. They tracked 683 participants over 30,000 treatment days with excellent safety results. So this is very interesting. I like where it's going to be able to, just put eye drops and go. I think it'll make it more available to people. I think we just need a little bit more information on who or what type of people would be affected by the irritation or the headaches and that kind of stuff. So we could, know that kind of stuff. This is great. Go ahead.
Yeah, what I'm worried about is the long-term effects. So this is, you're doing something that's not natural to your body. You're forcing your eyes to do something. You're tricking them. I don't know if you're tricking them or if you're just, I don't know. I'm worried about the long-term effects of this. That's my concern, right?
Absolutely. Like when you talk about doing something like this that doesn't affect the whole eye, just the pupil, you don't get the zoomed in effect. You don't get a lot of these other aspects. You got to wonder what the long-term effect of this. And this is sample distribution begins, like you said, October 2025 and full availability mid-November 2025. So we're not talking about far away. You'll be able to order this probably next month and start playing with it. So, and the market benefit, more than 128 million potential patients in the United States. And I think that number is probably smaller, is lower than you think. It is.
Oh, for sure. Because you have all these people that don't say anything, right? So, and you know what? It's reasonably priced. So from what I read, it's positioned to be priced around $79 to $80 per month for direct physician ordering. So it's preservative free though. And it's got single-use vials. So it does kind of address concerns about chronic exposure to preservatives, which can cause ocular surface toxicity with long-term use. So that is one thing that kind of they've eliminated, which is great. but yeah, I price point's good. They're not looking to gouge people, which I like. But I'm just, yeah, my concern is longevity, right? But there is, so Viz is entering a market that's currently dominated by Vuity, VUITY. I don't know if you heard of that one, which was the first FDA approved presbyopia eye drop. It came out in 2021, but the key differentiators are that Vuity provides approximately 6 hours of effect and requires multiple daily doses for substantial benefit, while Viz offers up to 10 hours of efficacy with only one daily dosing. Also, Vuity's dual action on both iris and ciliary muscles can cause accommodation-induced myopia and making distance vision temporarily worse, which is a significant limitation for many patients. So that's why before we were talking about what Viz actually does. But this is cool. I'm excited for this. I know a lot of people who use cheaters, those cheap glasses that you buy at the drugstore.
Yeah.
This is significantly more expensive than that, but hey, if it works and you don't have to worry, like you just put them in the morning and then you're good for the day, then I think this is, and it doesn't have long-term effects. I think this is great.
Yeah, we'll have to see. You talked about the price, but since it is going through prescription, that means multiple people will be getting their hands on it. So
it'll skyrocket.
Yeah. How's it gonna? So, and we'll have to see.
Go ahead. $79 to $80 in Europe.
Fair enough, right?
Yeah.
It just is what it is. I love this concept. We do have to look at the long-term safety effects and what it means. But less reduced dependence on corrective lenses, no need to carry reading glasses everywhere, easier to read during difficult lighting situations, and more confidence in social situations. And I guess you can feel like you put off the aging process as you get over 40. And your eyes start to not do what they used to. You can start just putting these drops in and still pretend like you're a young person.
Yeah. So I think this is great. Yeah, go ahead.
Yeah, let us know what you think about these drops, and how would you be jumping in and using? Do you want to wait to see what the long-term efficacy and side effects are, or is this something you would embrace right away? I'd love to hear your feedback. There we go. Scientists have achieved what once seemed impossible: reversing time in quantum systems. Quantum time reversal involves manipulating quantum systems to revert to previous states through experimental techniques. The breakthrough connects fantasy of quantum time travel with real scientific advances, allowing tiny quantum particles to return to their early states with remarkable precision. The study, titled "Quantum Breakthrough Enables Scientists to Reverse the Flow of Time in Quantum Systems," was published on June 4th, 2025. This research opens a new possibility for quantum computing and fundamental physics research. Have scientists reversed the arrow of time, John?
I don't know. So this is interesting. So just to kind of the experiment that they did. So yeah, let's dive into this. So they used a device called a quantum switch and a sophisticated optical equipment. And they were able to make a photon return to its exact state before it underwent any changes. So think of it like this. It's like watching a movie scene in reverse, except the particle genuinely travels backward through its quantum evolution without the scientists needing to know what happened to it in between. I'm thinking of the movie Tenet as I explain that. So why this matters, right? So the discovery actually could revolutionize quantum computing. And the way it can do that is by providing an undo button for quantum errors. Because when quantum errors make a mistake, which happens frequently due to their extreme sensitivity, this technology could automatically reverse the error without needing to know what went wrong, which is crazy. It also challenges our fundamental understanding of time's arrow and opens new possibilities for quantum technologies. Now, there's a lot of limitations here. While amazing for particles, this technology can't reverse time for humans or large objects yet. The scientists estimate it would take millions of years to rewind just 1 second of a human's quantum state due to the enormous amount of information involved. So no DeLorean Back to the Future stuff, at least not yet. What are your thoughts?
Well, you got to start somewhere.
Yeah.
And, scientists can now, researchers can now select a specific earlier quantum state to revert particles back to. So this is, it feels, again, magic. Try something, nope, go back, try something, nope, go back. It's almost like life is like a video game with a save button,
It's like a Control Z, yeah.
And undo, right? You go say, okay, I'm going to save it here. Then I'm going to try this. Oh, I didn't like that. Let's go back to my save point. Let's try this. Didn't like that. And now if you can do that with the real world and physics, this becomes an interesting, but we're talking about quantum states. And that we can now go back 95% with 95% accuracy. This is really interesting. And the fact that error states have always been the bane of quantum computing, and since the beginning it has been hard to tell whether you actually got a right answer or it was just another error and it just got the right answer by accident. So knowing that now we can detect them and automatically reverse them without even knowing what it was potentially, and build that into these quantum chips, I think is a major breakthrough. It's gonna be a game changer for all of this.
I agree. Yeah, and you and I have a different visibility on this because of all the technologies we've covered and advances we've covered in quantum. So beyond quantum computing, though, the time reversal protocol actually has potential applications across quantum technologies themselves. So, for example, in quantum cryptography, the ability to reverse quantum states could enhance security protocols or even enable new forms of quantum communication. For example, in quantum sensing and metrology, time reversal could be used to enhance precision by canceling out unwanted environmental effects. The protocol's ability to work without knowledge of the system's internal dynamics, it makes it valuable for characterizing unknown quantum systems, which could accelerate quantum technology development by providing a tool for probing and understanding new quantum materials or devices without requiring detailed theoretical models. So, there's a lot more applications than just quantum computing, which is great. But I think that the big thing about this one is this research challenges our understanding of why time has a preferred direction, right? Which I think is crazy. And there's a lot of people who are saying time is not linear and all this sort of stuff, but I don't know. I don't know enough to have an opinion on that. What about you?
Again, I don't know enough to say time's not reversed, whatever. Like all the rules that we previously thought around science and the world and laws have all been broken at some point in time. Maybe not all of them, but they've changed. So it's going to change again because, like, I foolishly say that quantum is magic. We don't really understand it yet, but it can do things in the physical world that are completely unexplainable. So as we start to traditional physics, not necessarily quantum physics. So as we jump to this new level of understanding of how the universe works, we're going to have these like magic discovery. So I'm really interested in this because when you start looking at quantum computing and a lot of limitations, a lot of the quantum computing power goes to error control. So we've talked about this, we have 4 chips that, or 4 qubits that do processing and 3 qubits that do error correction. Great. You know, if you can start now saying maybe we can eliminate a lot of that because we can detect and go back with these reversals, error correction through time reversal represents a paradigm shift in computational strategies. We may be able to bump up our time significantly. And this is a universal qubit compatibility, which is differentiates itself from earlier stuff. So this has more wide approaches than anything that has happened before because it's compatible universally with the qubits out there. So this discovery may influence broader theories about time's nature and physics that we have yet to understand, but I'm really interested in following this and what it means. We're like you say, we're not, it's nowhere near, we're not going to be able to send a human back in time anytime soon. But that doesn't mean that's not possible 100 years from now or 1,000 years from now. But we talked about those time travel theories before that you can't go back in time to before the time travel machine was made based on, you know, these theories. But that might be proven to be incorrect too.
Exactly. Yeah, you never know. Like these theories, until we can actually test them in the real world, are just theories. That's all they are. So theories are disproven all the time. So you never know.
So I'd love to know what you think about the quantum computing, the time reversal, qubits, error correction, and what this means for quantum systems and what it means for the physical world going forward. Are we going to now have laptop computers that have quantum in it that can reverse any errors in programming, logic, all that kind of stuff, or do some things that we never thought possible in the future? We'd love to hear what your thoughts are. Leave your comments below. Military AI represents the advanced integration of artificial intelligence in modern military applications, transforming how nations approach defense and combat operations. This revolutionary technology is reshaping aerial warfare that could fundamentally alter global power dynamics. Recent developments from China have introduced groundbreaking infrared AI systems that could challenge U.S. air superiority, particularly affecting the legendary F-15 fighter jet. This post examines, or we're going to talk about this, how this new technology impacts aerial combat. So basically, they're saying that they have new technology from an AI level that scans the infrared heat of what's going on the jet, what the movement of the pilot, as well as different changes in what's going on with the jet to anticipate what they're going to do and beat them at their own game. What's going on here, John?
Yeah, this is cool. So they've developed a system that addresses what researchers call the trajectory prediction problem in AI air combat. So just to kind of put it into perspective, traditional AI systems relied on mathematical models, and those predicted aircraft movement based on current flight paths, which essentially drawing lines into the future based on where an aircraft was going. Now, human pilots could exploit this by making sudden nonlinear maneuvers that broke these predictive models. So the breakthrough involves using a modified YOLO V8 neural network. YOLO is you only look once. I think they're up to version 11 of YOLO, so this is kind of cool, to analyze infrared imagery with ridiculous precision. So YOLO V8 in version 8 is already a cutting-edge object detection algorithm, which is using computer vision. But they've adapted this specifically for real-time analysis of aircraft control surfaces during combat maneuvers. The system itself can detect millimeter-level deformations in control surfaces. So, for example, tiny movements in the F-15's 1.5 meter rudder or 2 meter elevator surfaces. It essentially watches the aircraft's body language, tiny movements of wings, rudders, everything, and kind of like reading a pilot's intention before they're fully executed. What do you think about this? I love this.
Well, I mean, it's really cool technology, and it, we talk about this as China and they're leap forwarding us and it outsmarts Top Gun. It doesn't outsmart them, it's just ahead of them.
Yeah.
So how quickly to other AI start adopting this, like the US Fury drone, version 2, version 3, whatever it's going to be. We talked about that a while ago, which is the fully autonomous air-to-air combat plane that fills in that piece of air to ground, ground to air, and now air to air. If it's going to implement something like this, then what, it's game over all across the board. So that pilots will be eliminated faster than we think, and maybe that's a good thing, because I don't like putting humans in the way when we have these conflicts. But at the same time, as soon as the more drones we get that are killing machines, the more people will die. So I love the technology. I just don't like the fact that what it's going to be used for.
Sure. I totally agree with you. Yeah. I love the technology, and just scared of the practical uses, right? So, but my question to you is, what if you had an AI that was aware of this tracking AI? Would it be able to outmaneuver or outsmart the AI that's tracking it?
Absolutely. So all of a sudden you now build infrared and heat technology into the shell or into the jacket or into whatever either the person has or, the seat, and you can start projecting whatever you want. Or you could just project a huge mass so you can't tell anything that's going on in there because the heat signature is just overwhelmed by something.
Yeah.
So there's ways to start, as soon as these things come around, there's people or technology that'll get around it. But I started saying, okay, this is very interesting. And where I think this becomes interesting is when it gets down to the commercial level. And now we say, all right, great. Can we put this in cars? Can our cars now predict what the car in front of us and behind us are going to do with this same type of technology? Doesn't have to be obviously at the same speed, because we're not doing at 600 miles an hour dogfighting in the air. But will this now be put in robo taxis and Teslas and whatever? Maybe not now, but in 10 years, 20 years, that'll make them safer and more reliable. And this is a thing for the future.
Yeah. You know what? Yeah, that's great. Like, let's hope that they use this for good, and it can be implemented into cars, because I don't know if you've been seeing, there's a lot more crashes that are happening lately, with the autonomous driving systems. So they need some sort of advancement. I don't think it's, to be honest though, I don't think it's a matter of having this installed. I think it's more of a matter of the object detection and working with how to feed the environment into the system. I think that's the biggest drawback of these autonomous systems, but that's just my opinion. I don't know about you.
Yeah, we can talk about driving and the issues related with that in a bit. So like some other time. But I love, research has found that indicate that even highly agile aircraft like the F-15 become virtually defenseless against these predictive technologies. The F-15's renowned maneuverability, which has dominated air superiority for decades, faces unprecedented challenges when opponents can predict its movements. Predictable control surface responses, thermal signature patterns during maneuvers, structural deformation telltales, and limited ability to mask mechanical precursors. So the F-15 vulnerability extends to other traditional fighting aircraft that rely on pilot skill and aircraft agility for survival. The infrared AI system effectively removes the element of surprise that pilots have historically used to their advantage. Historically, AI versus human pilot encounters, the humans would do unpredictable stuff potentially to win, and that AI didn't predict.
Yeah.
Now that takes all that away, and now they know what you're going to do, and it's going to be next to impossible for humans to have a chance.
Yeah. And I guess if an AI is being tracked, will, other than the infrared, will it fake out the AI by doing small little changes so that the AI won't be able to predict? I don't know.
Yeah, so the next generation countermeasures we're talking about, military strategies are already considering these advanced stealth technologies to mask thermal signatures, rapid control surface actuators to minimize detection windows, electronic warfare systems to disrupt infrared sensors, and the development of red eye AI systems to enhance defensive capabilities. And the emergence of red eye concepts represent potential next generation tools that could enhance strike position while providing defensive measures against predictive combat systems. So, this is interesting. And their approach is different than the Western approach. Like the Western approach has always been radar-based targeting system, electronic warfare capabilities, network-centric warfare coordination, and GPS-guided precisions. China's new approach represents a fundamental departure of that, which now includes infrared thermal analysis, mechanical deformation detection, predictive behavioral monitoring, and real-time structural monitoring. So, the completely different approaches on how AI handles these things. And I think, we're going to learn off each other, and like all AIs, we're going to leapfrog each other. So these are very interesting technologies, and, learning and learning and learning, where the air is going to be controlled by AI in the near future. There's just no doubt about it.
Yeah.
So we'd love to know what you think. Is this, again, the impetus for Skynet once AI controls air to air, air to ground, ground to air, all those military implements? Now Skynet can control everything. Are you afraid of this future of military AI, or are we need to embrace it? And it's, one of those things that is the next step in evolution, and we shouldn't necessarily be afraid of it. We'd love to hear what your thoughts are on the future of AI and military. Leave your comments below. So what do you got going on, John?
Yeah, Flowgrammer event, Startup Drinks TO, and then next month will be beginning of next month will be Elevate, which was one of my favorite conferences. Just working away. How about you? What do you have?
Well, we've got Flowgrammer stuff all summer long, so it's August. Next one's in a couple of weeks, but this will come out end of September. So yeah, definitely got October stuff coming on. Check out Startup Drinks, flowgrammer.ca, torontostarts.com for all our stuff. Yeah, and we'll be at Elevate, not Elevate. Is it it's not what's the conference? Is it Elevate?
Elevate.
Yeah, sorry. There's so many of them. I'm like, damn it. I thought we just had that. No, we'll be at Elevate, and we'll probably be running an event during Elevate as part of a complimentary series. But we'll let you know a little closer to that. So check out all our stuff there. We help startups. We help companies automate their business. We also help people get out of their own head when it comes to startup coaching and taking their business to the next level. So check out torontostarts.com for all those things. And John, if people are looking for non-dilutive funding, where do they go?
Yeah, feel free to find me on LinkedIn. John Irwin on LinkedIn. If you have any questions about non-dilutive funding, government funding, happy to answer any questions.
And thanks everyone for watching. That's it for this week.
Thanks everyone.